Okay, get this ready. We're diving into a world where computers could design stuff like atom by atom, create medicines, and solve problems that would take forever, like longer than the universe exists.
You're not kidding.
That's the potential of quantum computing. And there's this recent announcement.
From Microsoft, right?
Yeah, it has a lot of people talking.
I'll say.
The title of their video, it's Majorana 1 Explained, The Path to a Million Qubits.
A million qubits? That's just wild.
I know, right? A million qubits, it's hard to even imagine. But before we get too deep into that, let's break it down. What does it all mean? Why should anyone even care?
Well, that's what we're doing today, right? Unpacking Microsoft's claims.
Exactly. We'll figure out what makes their approach different and explore what kind of impact it could have.
And what challenges they face on the path to a million qubits.
Yeah, exactly.
So the first thing you got to understand is why we need quantum computers in the first place. It all boils down to the limits of what we have now. Even supercomputers, the most powerful ones, they struggle when it comes to simulating the quantum world.
Simulating.
Yeah, like trying to model how just 30 or 50 electrons behave.
Sounds complicated already.
Oh, it is. To simulate that with our current technology, it would take longer than the universe has existed.
Wow.
But a quantum computer could potentially do these simulations easily because they work on the same principles as the systems they're trying to model.
Okay, so that's the why, but how would we even do that?
It's all about qubits.
Qubits, right?
They're like the building blocks of these quantum computers. Unlike bits in our regular computers, which can only be a 0 or a 1, a qubit can be both at the same time.
Both at the same time?
Yeah, thanks to quantum mechanics.
Right, I've heard about that. That's called superposition, right? Where a qubit can be in multiple states at once.
Exactly, and that's where the power comes from. It's like checking out every possible solution to a problem at the same time.
That's incredible.
But there's a catch. Qubits are really fragile. Any disturbance, anything, any noise can cause errors. Then the calculations get messed up.
So it's like if you're trying to balance a stack of coins on a table and someone bumps it,
Perfect analogy.
it all comes crashing down.
Yep. And that's where Microsoft comes in with their big breakthrough. They're focused on a special type of qubit. It's called a topological qubit. And these are designed to be much more stable. They're more resistant to noise.
Okay, topological qubits. Now we're talking. What makes these different?
It's all about how they store information. Instead of relying on a single particle, which is really fragile, they use the behavior of many particles together. Imagine like a message written in sand.
Someone could just walk by and wipe it away?
Right. But what if that message was carved into stone?
Much more permanent.
Exactly. That's the kind of stability we're talking about with these topological qubits.
I see. So how do they create this stability?
It's a new type of material. It's called a topoconductor.
A topoconductor, all right. Break that down for me. What is it?
Well, it acts like a semiconductor and a superconductor, both at the same time. This unique property allows them to host a special particle called the Majorana fermion.
The Majorana fermion, those sound familiar? Were those theorized like 100 years ago?
Exactly. It's only been recently that scientists have been able to actually create them and control them. It's a huge deal, a huge accomplishment. But what makes these particles really special is that a Majorana fermion is its own antiparticle.
Its own what?
Antiparticle. So think of it this way. Every particle has an opposite, an antiparticle. When they meet, they destroy each other. But a Majorana fermion is its own opposite.
Wait, so it's like its own worst enemy.
Kind of, yeah. It gives it some very unique properties.
I'm starting to see why this is such a big deal. But how do these strange particles, how do they help with quantum computing?
So by braiding these Majorana fermions together, inside this topoconductor, you can create a qubit that's protected from noise. Imagine it's like a shield.
A shield made from the fabric of reality itself.
Exactly, and that's where the million qubits part comes in. This approach, it could allow us to build computers with way more qubits than we've ever seen, all on one chip.
Wow, that's mind-blowing.
It really is. We're not just talking about small improvements. This is about solving problems that are impossible, even with the best supercomputers.
Okay, let's get specific. What kind of problems?
One area is material science. Imagine being able to, like, simulate new materials.
Atom by atom.
Yeah, exactly, with incredible precision.
So we could design materials that are way lighter, stronger, more efficient, stuff we can only dream of now.
Right.
And think about what that means for aerospace, for construction.
Even energy production.
Yeah, we can make completely new batteries, solar panels.
It's not just about new materials, though. Quantum computing could change how we discover and develop new drugs.
Okay, how so?
Well, right now, it's a really slow and expensive process. Lots of trial and error. But with a quantum computer, you could simulate how molecules interact really accurately.
So we could design drugs that only target certain diseases without bad side effects.
Exactly. And there's more. Quantum computing could supercharge artificial intelligence like AI.
AI, yeah. That's a hot topic these days.
It is. We could have algorithms that are way faster and way more powerful. This could lead to big breakthroughs in all sorts of areas like natural language processing, image recognition, even self-driving cars.
Wow, so AI that can solve problems that are beyond us right now.
Pretty much. But it's not all sunshine and roses. There are challenges too.
Right, of course. Nothing's ever that easy. What kind of challenges are we talking about?
One of the biggest is just building these quantum computers. They need to be big enough and stable enough to handle these complex problems. Right now, we're limited to a few hundred qubits.
Qubits, right?
And these systems, they still make a lot of errors.
So we need to figure out how to scale up the number of qubits,
Yes. And make them more stable.
which I imagine is incredibly difficult.
It is. It's going to take breakthroughs in, well, everything really. Materials, science, engineering, even our basic understanding of quantum mechanics.
So we can build them, but then we have to figure out how to program them.
That's another huge challenge. It requires a totally different way of thinking.
Not your average coding boot camp, then.
Nope. We need new algorithms, new programming languages, even a new way of thinking about problems.
It sounds like we need a whole new generation of programmers.
We do, and we need to start training them now. This field, it's all about computer science, physics, math, even a bit of philosophy.
Wow, that's intense.
It is, but it's also a huge opportunity. We're talking about creating a whole new field, a whole new area of knowledge.
A chance to be at the forefront of something truly revolutionary.
Exactly. And it's not just about the science and engineering, it's about the potential to change the world.
It is a lot to take in. But before we get completely lost in the future, maybe we should come back to the present for a minute.
Good idea. We've talked a lot about the potential, but we need to be realistic about the challenges too.
It's easy to get carried away with all the possibilities.
It is. But building a million-qubit quantum computer, it's not going to happen overnight. It's going to take time. It's going to take resources, a lot of hard work.
And it's going to take a lot of smart people.
Absolutely. Scientists, engineers, investors, people who aren't willing to take risks and, push the boundaries of what's possible.
So for our listeners out there, what can they do if they want to learn more about this, about quantum computing? Maybe even get involved.
There are tons of resources online. Courses, articles, videos. You can even just start Googling.
Just be careful not to fall down the rabbit hole.
Oh, yeah, for sure. There's a lot of information out there. But hey, that's what makes it so fascinating, right?
You got that right. This has been a truly enlightening conversation. I feel like I have a much better grasp on what quantum computing is all about.
And we've only scratched the surface.
So we've covered a lot of ground, right? From these mind-bending qubits to all the potential applications. This tech, it could really reshape everything.
It's a huge shift in how we think about computing. We're going way beyond what we know and stepping into this quantum world.
But it's important to remember, we're still in the early stages.
Oh, yeah, for sure.
It's like we've just taken the first baby step, glimpsed the potential, but the real journey's just beginning.
Exactly. We're still trying to figure out how to build these quantum computers, how to program them, how to really use them to solve these real-world problems.
And as we figure it all out, it's companies like StoneFly who are going to be key. They're providing the infrastructure, the support. They're the ones making it all possible.
They're the pioneers, laying the groundwork for this whole quantum future.
StoneFly, they get that the future of computing isn't just about the tech.
It's about the people.
Exactly. They're investing in education, research, partnering with universities, you name it, creating chances for the next generation, the quantum pioneers.
It's pretty inspiring to see a company not just focused on making money.
Right. They're focused on the bigger picture. How can technology solve the big problems?
Yeah.
So before we wrap up, let's look ahead a bit. What's coming up in the world of quantum computing? What trends and developments should we be looking out for?
Well, one thing that's really exciting is that quantum computing is becoming more accessible. There are these cloud-based platforms now, so more researchers, developers, even businesses, they can all get involved.
That's huge, right? More people can try out these quantum algorithms.
Develop new applications, really contribute to moving the field forward.
And more access means faster innovation. We'll see new algorithms, new software, new hardware.
Exactly.
And we can't forget about security.
Oh, that's right.
Quantum computers, they could pose a big threat to our digital security, all those encryption algorithms we rely on.
That's where StoneFly comes in. They're already ahead of the curve. They're developing solutions to protect our data in this new world.
They know that security is everything, so they're staying ahead of the game when it comes to new threat.
Absolutely.
If anyone out there is looking to navigate this whole quantum landscape, StoneFly is a great place to start.
Oh, yeah, definitely. They're a trusted resource, providing support and solutions no matter how big or small your organization is.
So if you're interested in quantum computing, check out what's available online. There's tons of stuff out there. And for those who want to dive deeper, I highly recommend checking out StoneFly. Their website is www.stonefly.com, and their sales team's easy to reach at sales@stonefly.com.
They're not just building technology, they're building the future.
Well said. It's been an amazing journey. We've explored the science, the potential, the challenges. It's clear This is a technology that could change everything.
And we've seen how companies like StoneFly are making that future a reality.
To all our listeners, we hope this has inspired you to learn more, stay curious, and keep exploring. The quantum future is bright, and it's up to all of us to make it a good one.